Hi, and welcome to this mini course on VLMs, or Vision Language Models, which is a step towards having images as input with text to output, more text so you can ask questions about an image. This is really exciting since was the first step towards multimodal models, and I'll describe a little bit of the impacts and how to run it on AMD Developer Cloud. So specifically, we'll be looking into OCR, or optical character recognition, of using VLMs for that long-standing task, but also share a little bit more of what else you can do with these powerful language models. So first, why? Why would you want to use this stuff? Well, wouldn't it be cool to copy a photo of your coffee cup from Starbucks, for example, and be able to order, from there and be like, hey, I want the same thing as this person. Take a snapshot and get the text from it and then automatically order something. You could also imagine getting ingredients from a nutrition label. I often go buy food and I just want to know, what are all the ingredients, and I want to put it in to some, ingredient looker to see if I'm allergic to anything, or how healthy certain ingredients are, or how simple they are. And finally, you could copy words you don't know from a menu and look them up. So you can easily just take a photo of a menu and it'll be able to figure out and parse all the words there. And maybe it's, Italian and you don't know all the words on that fancy menu. And you want to go put that into some kind of translation app after. So these are, use cases for VLMs. So exactly what's happening under the hood, though, right? You want to go a level deeper. So first, we're all kind of familiar with large language models, right? You input text, you encode that text, you turn them into tokens, and then you learn a representation of those tokens. So you learn the model learns how to output the next token based on all the tokens it's seen before. And from that process, it learns a lot of general knowledge about text and understanding, and that's why we think they're so powerful and intelligent. And for a vision language model, it's slightly different, right? It still has that text as input and text as output, but now you have an image input in addition to the text. And what that image is doing, you want to encode that image, those pixels, into some kind of tokenized representation as well, a different type of tokens, different kind of encoding, but it turns into some kind of vector representation, and then you turn that into some kind of embedding as well. And specifically, you want to be able to embed it in a way where you can easily combine it with your text embeddings. So these are both vectors, and you want them to be similar shapes so that you can actually be able to combine them easily. And then once they're combined, you can, learn additional things on top of that, which is their combined inputs, to produce the next token output of text. And that's your text output. Here's a very simple example. You might have a picture of a tree, this tropical tree, and the word tree is going to embed hopefully very closely to this image, or be able to offer similar, tokens and embedding space to this image. And it's also able to then output relevant tokens based on your text input. And an LLM is not able to do this well because it can't encode images in, right? So it can't actually take these images in, these pixels in, and turn them into tokens, because those are not even in your vocabulary, only text tokens are. But a VLM can. So a VLM, you can take this same image and you can ask a question, how many trees are in this photo? And it's, embedding, tree in there, but it's also embedding this question. So you can ask semantically what's going on. And then it's able to produce text output, each token out there, and say there's one tree or one, right? And so it's able to produce something sensical out of that, because the LLM piece is really thinking through that representation. It's really thinking through that concept, just as a regular LLM. Combining this with OCR is pretty critical. OCR, optical character recognition, it's been around for a super long time to automatically read receipts or automatically read a scanned document of a PDF or a paper page, and be able to take that handwritten content or messy content in some text in some way and be able to transfer that into something digital. And so that's been around for a super long time. So instead of, a handwritten note, perhaps, maybe we're writing something in the sand. So here is the word love written in the sand. And to programmatically extract the word love, that's a pretty difficult task. It can show up in a lot of different ways, a lot of different fonts, and it could be hard to read in some instances. So being able to extract this is a very powerful task. So a VLM can actually do this, right? So you can say, extract the text from this image, or what is written in the sand in this image, and it should be able to take this image and then be able to produce the word love. And the strength of VLM-based OCR is it's able to handle pretty complex scenarios, and it's able to understand almost the context a bit better, and you're able to ask pretty complex questions of the actual image. Instead of, traditional OCR-based systems, all it did was OCR. You weren't asking any kind of like general questions. It's just extracting text. But here you can actually ask questions that are relevant to you about this image, and it can produce the output that you desire. So if you only cared about that tree previously, for example, or how many trees, it would just say one tree, as opposed to saying there's a sky, there's this, right? So that's what's really powerful. Now for OCR, you can ask questions of something written down on a notepad from a meeting, like how to request time off, right? Or request PTO. So it's able to make this process much easier. And so it's a very, very powerful model to combine these two types of inputs. So a fun little thing, so as a team, we went out onto the beach and actually wrote out something on the sand. I love AI. Amazing. And then the water rushed out and it got some of the I love part. So let's go test some of this out. So the original I love AI. So seeing this, a VLM-based system might try to figure out like what exactly is being written here. Is it I love AI? Is it I love Al? Well, hopefully it has enough contextual information that it does see that, love is capitalized, so therefore AI is probably going to be capitalized, right, as well. And it understands this contextual area of like it's in the sand, so it might not be super clear in terms of what's being written, and it might have seen other things written in the sand before as well. So hopefully it's able to extract I love AI. Well, let's give it a spin in the AMD Developer Cloud. So you can just run this notebook super easily. It's already out there. And you can run this VLM here. It's Llama 3.2, and it was able to extract I love Avi. Oh man, so probably more likely, right, from probabilistic point of view, to write I love Avi, a person's name, rather than I love AI. But I do love AI, and I hope that VLM can get it next time. But it's still very powerful that it was able to extract that, and that is probably the more likely thing being written in the sand. It's also very robust. What I find really interesting about these models is how robust they are. So we tested it with, the water washing away the I love piece and seeing whether the model can actually still detect pieces of that text. And it turns out when we run the notebook, it actually was able to extract love still, which is really impressive, I think. So applications of VLM-based OCR extend even further to, healthcare, for example. So uploading handwritten notes from your doctor, which might be borderline legible, but taking those and being able to then transcribe those automatically and uploading them so that you can search them or give them to nurses or patients themselves. Being able to read and process different shipping labels or, things that have been beaten up as it's being shipped to you, but still being able to read that very effectively, that's important as well. And finally, just digitizing historical documents or articles. So with that, I hope you give it a spin. Go try it out on AMD's Developer Cloud and tell us what you built. I'm really excited to hear about it. And feel free to ping us for some free credits. Just mention this course.